We are moving on to lesson 8.9. We're going to skip over 8.8 because that's one of the ways of solving that I don't have to make sure you know this year. You can learn that later. So we will move on to solving using the quadratic formula. Okay? So our learning goal today, I can solve a quadratic function using the quadratic formula. We have learned that some quadratic equations can be solved by factoring. Not all of them. We've learned that some quadratic equations can be solved by using the square root method. Not all of them. But when we use the quadratic formula method, the quadratic formula can be used to solve any quadratic equation. It doesn't matter what it is, as long as it's a quadratic equation set equal to either 0 or y, it can be solved using the quadratic formula. Okay? So here it is. It's a lovely formula, quite long. X equals, here's how we read it. The opposite of b, that negative sign in front of b means the opposite of b, plus or minus. That takes care of the fact that there's a positive and a negative square root because we're going to be taking a square root following that. We're going to take the square root of something called, it's called a discriminant, b squared minus 4ac. And then that whole numerator, that whole thing I just said, has to be divided by 2 times a, or 2a. So this will always get us solutions for our quadratic equation. Whether we say there are 2 solutions, 1 solution, or no real solution, it will get us to one of those choices. Okay? So the first thing we need to do is make sure that we have an equation, a quadratic equation set equal to either 0 or y, and then identify our a, b, and c. So since number 1 is already set equal to 0, go ahead and identify your a, your b, and your c, because I don't need to help you do that anymore. And then, when we substitute into the quadratic formula, we are going to use parentheses every substitution. Otherwise, it gets way too confusing. And the other thing we're going to do is we are going to, every time, we're going to work with that quadratic formula as, in fact, every time we write it down, it starts going to memory. Write it with me. X equals the opposite of b plus or minus the square root of b squared. But we are going to change that subtraction to add the opposite. So instead of minus 4ac, we're going to say plus a negative 4ac. Trust me, you'll be far more successful changing that subtraction to add the opposite. And then it's going to still be over 2a. Okay, our first step is going to be substituting in. So we're going to substitute. So we have x equals, remember that's what we're solving for. The opposite of, we're going to put a 5 in parentheses, our b value, in parentheses. Then we have our add and subtract, our little shortcut way of showing a positive or a negative, or add or subtract. And then we have, underneath the radical sign, we have to substitute in parentheses 5. And we're going to square that. Then we have plus our negative 4 times a, in this case our a is negative 3, times c, which in this case is positive 2. So far we've had 4 places we've done substitution, haven't we? And now downstairs, you need a big long fraction bar, just like you needed kind of a long radical symbol. Downstairs we're going to have 2 times negative 3 for our a. We have 5 substitutions to do. In the next step, we're actually going to do quite a few things, but then the following step we're not going to do as much because don't try to do too many things at once. So here's what we're going to do. We're going to take that opposite of b and we're going to name it. What is the opposite of 5?
Negative 5.
Negative 5. So now we have negative 5 there. What's 5 squared?
25.
25. Plus, Aaron, what's our negative 4 times a times c? That would be positive 24. And downstairs we have 2 times negative 3 class, that is negative 6. So notice we made the opposite of b. We really basically got rid of all of our parentheses.
We squared our 5, we multiplied our negative 4 AC, we multiplied our 2A downstairs. Now, we're going to do one thing is all in this next step. We are going to find out what our radicand simplifies to. 25 plus 24. 49. Good news. That is a what?
Perfect square.
Perfect square. So when it's a perfect square, in reality, that means solving by factoring probably would have worked. But we're learning the quadratic formula right now. So x equals negative 5 plus or minus what? 7. And now we're going to break this into 2 problems. Okay? So we have to do x equals negative 5 plus 7. That's going to be one. That's going to provide one of our solutions. And x equals negative 5 subtract 7 divided by negative 6. So let's go to this one. Negative 5 plus 7.
What?
2
Oh.
over negative 6. Negative 6 going to 2 nicely.
Negative 1.
So we'll leave it as a fraction, negative 1/3. Okay, so there's one of our solutions. There's one of our zeros of the function. And x equals, what's negative 5? Take away 7. Negative 12. And negative 12 divided by negative 6. 2. There's our other solution. So this one has 2 real solutions, crossing the x-axis at negative 1/3 and then positive 2. Would it open up or would it open down?
Down.
Down, because our A value was negative, wasn't it? Okay. Now, they do take up a lot of room, but the good news is I'm not going to make you check your answers. So you should do it. How would you?
Oh, never mind.
Put it back into your.
Got it.
So, okay. Anybody have any questions? Any part of this you did not understand? Well, there's more.
I see that. Just look at that.
Okay, let's go to the back side. Guess what that x equals is? It's there for you to fill in the quadratic formula. You have it memorized by now already, so go.
What? Oh, it's -3.
You don't need to tell the whole class.
They don't.
Let them work for themselves.
No.
And remember, it's best to write it as plus and negative under that radical sign because it will help you be more successful. Because trust me, there are no times today that it ends up no real solutions where you can't come up with at least one solution. And the majority of the time you will get 2. Okay, number 2. Is it ready to identify A, B, and C?
No.
Okay, what are we going to do? What do you want to
You
do?
gotta subtract 5x squared.
Okay, you want to subtract 5x squared? Okay.
Alright.
Now, could we have moved the 9x and the 2 over with the 5x squared instead? Sure. Should we all still get the same answers in the end? Even though we'll be working with different A's, B's, and C's, we still better get the same answer. So if you've been working ahead and this isn't the way you're going about it, in the end, we better get the same answers. Let's put that right side in standard form right away. Negative 5x squared. That's a positive 9x, so we would say plus 9x plus 2. Now, if you move the other 2 over to that side with the 5x squared, your A is going to be positive 5, your B is going to be negative 9, and your C is going to be negative 2. But it doesn't matter. It's okay. You just won't be able to follow along with us. So, do your A, B, C. And you got your quadratic formula written down up there, so you don't need to write it again. Go ahead and do your substitution step next. Parentheses for every substitution. So you should have 5 places where you substitute it in, there should be 5 sets of parentheses in that step. Mine are written in red if you want to double check to make sure you did it right. In the next step, we get rid of all those parentheses, clean it up. After cleaning up all those parentheses, your next step is just get your radican, simplified. Do your addition, in other words.
Oh, that.
I got a 121 for radicans. Do we like that number?
Yes.
Yeah, it's a perfect square, isn't it? What's it square root? 11, yeah. So x equals -9 plus or minus 11, all of that over -10. So the radical 121 becomes 11. And now we break it into those two problems. So now we have our x with the -9 having the 11 added to it. And we have the x with the -9 having the 11 subtracted from the -9. So I think the first one probably becomes x equals 2 over -10. This one becomes x equals -20 over -10. But of course, we're not going to leave them like that. So 2 over -10.
You want to turn it into a decimal?
You can turn it into a decimal because it's a nice one. Or
Negative 0.2.
-0.2 or -1/5, right? I tend to like fractions. I don't know, they're just kind of. And -20 divided by -10. 2. X equals 2. This one would have been factorable also. So in other words, when you get a perfect square radican, that number under the radical sign turns out to be a perfect square. That means it really could have been solved by factoring 2. But the quadratic function solves anyone. Okay, questions on? Now, notice something about the quadratic function. There's a part of that quadratic function we should recognize. Or quadratic formula, excuse me, I'm calling it the wrong thing. The quadratic formula, look at it. Isn't there a part of that you recognize? That we've used?
2a.
X equals?
2 divided by b squared.
We haven't really used the b squared minus 4ac part.
It's the 2a.
Mark? Oh. How about the negative b at the beginning and then that divided by 2a down here, so it's kind of like part of it we've used? What does the negative b divided by 2a get us?
Oh, that was the.
What did I use here?
That's the
Axis
that's
of
what we got.
symmetry, yeah, the axis of symmetry. Oh, but when we add the other part to it that we have, plus or minus the square root of b squared minus 4ac upstairs, now we're solving for the zeros or the solutions of the function. Okay, let's go on to that next page that says 8.9 notes 2. Because of course we know that life isn't always what we want it to be. So when b squared minus 4a squared is not a perfect square, you will need to round the answer. Okay, I'm not going to make you do the exact answers today. We'll just give the approximate answers today. Okay? So, write that quadratic formula. You have it memorized now. Go, write it. Don't cheat. Don't look anywhere. You know it. Right? Okay, now, we're on to the first one on this page. Are we ready to do A, B, and C?
Yes.
Okay, go ahead and do it.
Oops.
Now we'll do our substitution step. 5 places you should be able to substitute in parentheses, the A, B's, and C's where they need to go. So again, I caution you, you're not, experts at this yet. Don't try to do too much and not, take the suggestions I'm giving you. Okay, now when we get rid of all those parentheses, we have, what's the opposite of negative 8? 8. Negative 8 squared is 64. Plus negative 4 times 2 times 1, negative 8. And 2 times 2 downstairs is 4. Okay. In that next step, what's the only thing we do, Justin, in the next step? Do you remember? It's just we only do one thing. What is it? Maura? Do what's under the side of the radical sign. Simplify the radicand, that's called. The 64 plus negative 8 is the radicand. So we're going to say x equals 8 plus or minus the square root of what?
56.
56. And that is over 4. 56 a perfect square?
No.
No. So that means this is the one where we're going to have to round. We're going to have to approximate it. Now, what we're going to do is, we're not going to approximate square root of 56 right here in the middle of the problem. We're going to break this into our 2 problems, and we're going to learn how to put it into our calculator to get the best possible answer we can get. So we're going to have x equals 8 plus radical 56, all over 4, and x equals 8 subtract radical 56, all over 4. But here's the deal. That whole numerator has to be divided by the denominator. So we have to put, and it might be a good idea in your notes even to do it, we need to put that numerator in parentheses, and then it will add those 2 together first, and then it will divide by 4 like it's supposed to. It will, otherwise it's not going to know what you really want it to do. Okay? So go ahead and try that in your calculators. 8, we're going to start with a parenthesis, 8 plus radical 56. So I think some calculators in here do this. When you put it in, and you're, typing along, and you do this radical sign, it makes another parenthesis. Anybody's calculator do that? Yeah? So now I made a parenthesis here, so you're going to put a 56. You have to close that parenthesis and say, I only want you to take the square root of 56, calculator. So you close it, now it knows it's done taking the square root. And then you do another parenthesis to close that one, so it knows it's done adding now. And then you do divided by 4. Okay? So you have to know how to talk to your calculator, basically. Those of you who don't have a calculator, I need collateral up on the file cabinet, and you get one on the top drawer. And collateral is not like, a comb. I don't want a comb. I want serious business. Yeah, go.
Serious business.
I'll take your shoe underneath the table, I
No, I
guess.
don't have to let.
You can learn a pencil.
You gotta know how to do these. And you gotta use the approximately equal to sign in your solutions because you are rounding. And you do not need. Don't be picky, take a calculator and go sit down.
Who gave her their math?
So after everybody's actually tried it, I'll put out there what you should get. Round to the nearest 100, like we did yesterday. Round carefully. We need to be as accurate as possible, in other words.
Apparently I'm number one.
So, until you actually get the first one, an answer on your screen, you are not to look up here because you need to make sure you can make it happen. And round to the nearest 100. If that is not what you get after you check, then you're not putting it into the calculator correctly. Some of us may not need these other parentheses here. We may just get to do this. It may not make parentheses for the radicand.
Or did that come?
And the other one should turn out to be that. So when you're doing the adding one, it should be the one on the left. When you're doing the subtracting one, it should be the one on the right. Those are your answers. Those are our solutions. These are the approximate locations the parabola would be crossing the x-axis.
So the divided by 4 is it in the front?
Nope, it's not in the parentheses.
Hey, I got that answer.
We need the whole numerator operated on first and then divided by the denominator. So the divided by sign is not inside parentheses. Okay, when you get those two answers, you can move on to the backside. Go ahead and start that one and try it. See what happens. It's already set equal to 0 for you, so you should be able to go right to work. I'm going to put these two answers up here so I can go back and start working. And if you, these are what you should get for numbers. Well, actually, this is number 1, isn't it? Because we're on a second sheet. I left you some space at the top to write the quadratic formula again. It's kind of nice to, kind of nice to have it staring you in the face there to substitute into until you get it memorized. And my substitution step, if you're not feeling confident, want to just double check. What is the opposite of 0, class? Okay. The opposite of 0 is 0.
Oh,
And then my question is, how significant is that 0 upstairs at the beginning? When we took the opposite of 0, we got 0. How significant is it? Can we like just kind of just ditch it, disregard it? In other words, can we, if we read this backwards, the square root of whatever plus 0, would that change the square root of whatever? No. If we change this to add the opposite, add the opposite of 0, what's the opposite of 0? So we'd still be adding 0. So is that 0 up front going to matter at all? No. So let's ditch it. And let's just have a positive or negative square root of 180 divided by 6. Now, here's what you can do. You don't even really need to divide this into two problems because there's not something plus that square root of 180 and something minus that square root of 180. It's really just a positive or a negative. We're going to end up with opposites for our solution. So we can say approximately equal to, we can bring our plus and minus down up front, and all we really have to do is put into our calculator the square root of 180. And if your calculator, remember, makes those parentheses around the radicand, make sure you close that parenthesis, and then divide it by 6. And I'll show you the answer that you should get rounded to the nearest 100. Use two solutions, but we can shortcut write it like we were doing yesterday. Okay, if you were successful, you are ready to start on homework. But if you really aren't done yet, don't pretend, because these are notes that are going to be helpful for your class, remember? So anybody have any questions right now that you need taken care of? Okay, all I'm going to do is stop the recording and get it started saving, and then I'll put these back up here so you guys can finish, but I don't want to keep